I didn't think
I got a chip stuck
Okay.
in my teeth.
Oh, that's awesome.
Hurts
Okay.
so bad.
Anyways, today what we're doing is adding and subtracting. Yay, 2 plus 2 and 3 minus 1, that kind of stuff. Now, adding and subtracting fractions. So before we get into the algebra part, we need to review, well, how do we do adding and subtracting of fractions when it's not algebra? So and I'm just going to do simple problems because my assumption is algebra students actually do know how to add and subtract fractions. So if we'll do just a simple question like this. In order to add these, what do I mean, I don't just do this, right? I don't say 3 over 7. It's not like that. Not that easy. What do we need?
Common denominator.
Common denominator. What is our common denominator?
10.
10. Does anyone not see why the common denominator is 10? Okay, now what do I need to do with this fraction?
Multiply.
Yeah, so I have 2 times 2, and then plus, what do I need to multiply this one by? 5. So 1 times 5. So I'm just showing a lot of extra steps here so that when we do this with the algebra, it makes a little bit more sense. All right, so 9/10 is our answer right there. And if I had, say, 3/7 minus 1/14, what's our common denominator? 14. And what do I need to multiply this fraction by top and bottom to get that denominator? Yeah, a 2. So I get a 6 minus, and what do I multiply this one by?
7.
Careful.
Nothing.
Nothing. Oh,
So a 1.
That's so funny.
Okay, so 14 times 1. Gentlemen. 6 minus 1 is 5. So 5, not 15ths, 5 14ths. And then it didn't happen in either of these examples, but our last step would then be to reduce. So now we are ready to take a look at the algebra portion. So what if I had, we'll start pretty simple, what if I had 2 over xy plus 5 over 3x?
This is simple.
Yes, this is the simple one. It is the same process as we just went through. I asked myself, what is the common denominator? And to get that, I look at the denominators of all the fractions involved, and I determine that. So I look at this fraction, I see an x, and this fraction also has an x, so x is part of my common denominator. I look at this fraction, I see a y. I look at this fraction, there's not a y, but this one does have a y, so y is also part of my common denominator. And then, this fraction has a 3, this one does not, but I still need that 3. So this is my common denominator, 3xy. Now, I take a look at this fraction, and I ask myself, well, what do I need to multiply this denominator by
3.
to get this, and I get a 3. So 2 times 3, right? So 2 times 3. I'm just going to write that out. Plus, in this fraction, the denominator is missing a
Y.
So I multiply this numerator by
Y.
and I get 5y. So in the end, I can go, now I can't add, which I noticed on some quizzes, the last quiz, some of you are adding unlike terms. Are these like terms?
No.
No, I can't add them. That's done the way it is. Now my last step after I actually get my common denominator and do this addition is to reduce. And to reduce, we do just like we did at the beginning of the chapter, where we factor and then we cancel. Now in this example, there's nothing that I can factor out. And can I cancel these y's?
Yeah. No,
No, why not?
because it's an addition.
Because I can never cancel through an addition. I would have to factor out a y and then cancel it.
And you couldn't reduce it because it's also not.
Right. Now if this 5 were a 6, I could factor out a 6 and then reduce the 6 with the 3. Let's try another one. One that, for whatever reason, ends up being tricky.
So can I ask you a question?
Yep.
In the first one, the common denominator was just one of everything that you had in the two denominators.
Right.
So-
I don't need 2 x's. I see this one has an x, this one has only an x. So there's an x in, but it's like this. 1/2 plus 1/2. I mean, my common denominator is a 2, not a 4, right?
Right.
So
you
2
had-
over 2, which is
If
1.
you had AB as a denominator and 3A as a denominator, you would have 3AB. Because
Okay, say again. I have in one fraction, what's your example?
AB,
AB. In the other fraction, we'll say a 1 right there.
2B.
2B.
So when you're
Okay, so I look at this. This one has an A, so I need an A. This one has a B, I need a B. This one also has a B, but I already have a B as part of my common denominator. This one has a 2, so I need a 2. All right, it works just like, so what do I multiply this fraction by? In order to get the 2AB, I multiply top and bottom by 2. And in order to get the 2AB, I need to multiply top and bottom by A. So, done. Okay, that's how I would do that. It works exactly the same as a case like this. What's my common denominator?
X squared minus.
Well, right here.
Oh, there.
What's my common denominator?
12. 6.
6, right? Is 12 a common denominator? Yes, but it's not the least common denominator. Hi, Noah. We're up here. So why is that? Well, if I prime factorize my denominator, I have a 3, right? I have a 2. This one also has a 2, but I don't need to repeat that 2. I already have it. So what do I multiply this numerator by? And this one by a 3. So I get 4, 6, right? Which then illustrates the next point. I could reduce to 2/3. All right, so now we are on my next algebraic example, which is right here. And I'm going to go ahead and move that up. I thought I was going to move it up, but I guess not. Oh, I can rotate it around. That's pretty cool. But that's not what I want to do. Oh, I'll just make it huge.
Okay, why don't you?
Okay, anyways, there it is. What's my common denominator?
X.
X squared.
X squared, because I have 2 x's right there and a single x here. This one has an extra x, doesn't it? So it's x squared. What do I need to multiply this by?
Nothing.
Okay, and when we say nothing, we mean a 1,
One.
right? Minus, what do I need to multiply this one by?
X.
So 2x. And I might put this in order. I mean, technically, that's our answer. We're fine. But if I wanted to put it in order, I would put it in this order, right?
Oh, it's
With the minus goes with the thing it's in front of. So it's negative 2x. The negative 2x stays the same. This is a plus 5. So the plus 5 stays the same. So that is it in the correct order.
Does it matter which way it's supposed to be in?
Well, technically we want this, because remember yesterday when we did dividing,
Yeah.
right? We need to put them in order.
But would you get upset and yell at us?
Yes. Okay, so let's say I have x plus 2 and a 5 right here, plus an x plus 3 and an x right here. What is, everyone should be writing this down, this goes into your notes. All right, what is our common denominator?
X plus 6. What would you have?
What would you do? X plus 2 and then X plus 3.
Yeah, this is a group,
Oh, you
and
would
this
do
is a
that.
group. So it's x plus 2 times x plus 3. I treat it as a group. So, what do I need to multiply the first numerator by?
X plus 3.
What do I need to multiply the next numerator by?
X plus 2.
What do you think you should do next?
Cancel.
No,
No,
I
we're
cannot
just-
cancel.
Reduce.
Distribute.
Distribute.
Why can't you
So,
cancel?
what
Oh,
do you
there's
mean?
addition.
I cannot cancel.
Well, there's
through addition.
multiplication.
There's a plus sign right here. So I need to distribute.
Boom.
Now what do you think you do? We distributed,
You would need to put it in order.
and not only that, do I have like terms?
Yes.
Oh, not 5x. 5x plus 2x is 7x plus 15.
Would we want to factor that out?
Which brings us to our next point. If I can factor, I do. Why do I? To test for canceling. Remember, the last step of any fraction problem is to reduce, and the way to reduce these is to factor and cancel. This happens to not be factorable, so I am done at this step. Now, if this were an 8 right here, then I could factor it,
Yeah.
okay?
I'm talking about factoring like x times x plus 5, x plus 3,
Say x what?
x plus, oh, never mind.
Okay. All right, so that's how we approach a problem like that. But sometimes our denominators are a little bit or a lot more complicated than just that. So,
If it was factorable, would you cancel?
yeah,
Let's say
I
it
would
was
try
an 8,
to,
you would-
okay, if it were x squared, I got this as my answer. Like, for some reason, this were an 8 instead. Same problem. But I got this, the only thing that changed is I added and I got an 8 there. I can factor that, and it factors to x plus 5 times x plus 3, right? And now, just like at the very beginning of the chapter,
Cancel.
we can cancel those, and this becomes my answer. Okay? Now, many of these are such that the denominators are more complicated than what we just had, something like this. Okay? What I do not want to do is use this whole thing as a denominator and this whole thing as a denominator. What I want to do to determine my common denominator, I want to factor my denominators. So factor, that's like a theme of this chapter. Factor, and then do all the work like you did in regular fractions. So when I factored the first denominator, what do I get?
X minus 3
x
and x plus 3.
And in the second fraction, when I factored that,
X plus 3 and x plus 3.
so now, let's take a look. What is my common denominator? Well, I have an x minus 3 on the first fraction, don't I?
So is it x plus 3 and x minus 3?
Hold on. I have an x minus 3. This one I have also an x plus 3. But how many x plus 3's do I have in the second fraction?
2.
2 of them.
X plus 3 squared.
So it's x plus 3 squared, or I'll write it like this just so that we clearly see it. But yeah, I have 2 x plus 3's in this second fraction. So I need to, it's like if I had x squared plus an x, right? Like this. My common denominator is not just the x, it's the x squared. So I have 2 x's on this first one. So I have two of these groups right here. So what do I need to multiply this numerator by?
I'm confused.
X plus 3. I will back up or do another example. What do I need to multiply this fraction by?
X minus 3.
X minus 3. How do I know? I look at my denominator. Just like a regular fraction, I look at my denominator. Look at these things I have here. What is this denominator missing?
X minus 3.
So that's why I have to multiply it by x minus 3.
Well,
And
I
then,
don't-
listen, and in this one, look at my denominator. I have an x minus 3 and an x plus 3. Look at this denominator. How many x plus 3's do I have? 2. So I need to multiply this one by x plus 3 and an x plus 3 because my denominator has 3, see, 3 pieces right here? Daniel, stop. All right, now what do I do?
You would distribute
Distribute. So I get x squared
plus 3
plus 3x plus 3x
minus 9.
minus 9. And then I combine that, I get x squared plus 6x minus 9. All over,
X minus 3x plus 3 squared.
yes. And this is my answer. If I can factor this, I do. It is not factorable. So you do need to try it though, I just happen to know that that's not factorable. Now, someone said they're confused. At what step were you confused?
Why didn't you put a squared?
I can. It's not wrong to.
Why don't-
Equivalent answer. This means exactly the same thing. The reason that I specifically did not write the squared is so that I recognize that I have 2 of these right here so that I can more easily figure out what I need to multiply my numerators by.
And I'm confused on another thing. 3 of the x plus 3s.
No, there's
Why?
not. There's 2 of them. Okay, it's again the same situation of right here. I'm adding these fractions. What's my denominator? This is a 3 and a 2, right? And this is plus a 2. I don't count this 2 twice, right? There's how many 2's in this first fraction?
Then why do you count the x plus 3s twice?
Okay, it's like this situation. 1/6 plus 1/4. What's my common denominator? 12. Why? Because I have 3 times 2 plus 2 times 2. How many 2's do I have over here?
2.
2 of them. How many 2's do I have here?
1.
1. My common denominator is 2 squared. It's going to be 2 times 2, and this one has a 3. This one does not, but it doesn't matter. I take a look at whichever has the most wins, right?
Oh.
Whichever has the most. This has more, so I take this. This has more, so I take that. That's my common denominator. But that's a skill that you should have learned, like essentially this same thing. Do you understand this 1/6 plus 1/4?
Sure.
We better.
Yeah.
Okay. And our denominator was a 12. All right. Let's do one more, and then that closes out this
Can I ask
section.
a question?
What?
If you were to have maybe 1 over 25 and let's say 2 over 37, and you had to
Those
find-
are relatively prime. You realize that, right? So you made this really hard.
No. I'm just asking if I could. When you find the common denominator,
Uh-huh.
can't you might have to simplify when you do this because it might not be the simplest one. Can't you just do 25 times 37
Yes.
and then divide 37 into that number? And
Okay, what do I need to multiply this by? I'm going to cut you off.
25.
So 2 times 25 plus, what do I multiply this one by?
37.
Yeah,
37.
37.
Okay, 37. Why, now you chose numbers that were relatively prime. You chose numbers that have no common factors, which is why what you just said, that trick is going to work and you're not going to have any problems. The reason you do not want to do it that way for a problem like this, these numbers are not relatively prime. They do have common factors. So what's 25 prime factorized? 1 over 5 squared. And this one prime factorized is 3 times 5, right? So this one has, if I rewrite this as 5 times 5, what is my common denominator? It is not 25 times 15. Now that is a common denominator, but I will have to reduce in the end. Which isn't a problem with fractions when we're dealing with numbers, but when we're dealing with algebra, you're causing yourself to need to factor unnecessarily at the end. And we
I know.
already struggle enough with factoring. We don't want to unnecessarily add extra factoring in at the end.
But
So what's
problems like that.
so what's our common denominator in this case? How many 5s do I need?
2.
2. So
And then a
5
3.
times 5 and a 3.
73.
So what do I need to multiply this numerator by?
3.
Plus, what do I need to multiply this numerator by?
5.
A 5. So I get 8 over
75.
75. Okay? If I didn't choose that denominator, I'd have reducing in the end.
Right. So when they're relatively prime, I can do that.
Right.
Right.
Okay? But you're going to have algebra. So you're going to have something more like this. So let's try x squared minus 4
Then I didn't need to.
minus 2 over, let's see here, x squared plus 2x minus 8, maybe?
Yeah, that'll work.
Yes.
Can I have my solid figures back, please?
Yes, they're in the back. Caitlin, would you give Mrs. C her toys?
Her toys. You're not gonna think they're too toyish, I don't believe.
No, they probably won't. They're playing with blocks over there in middle school, man. All right, anyways, what do we do first?
Factor.
Factor. Notice we're subtracting. All right, so we have x plus 2 times,
X minus 2.
and this numerator, what do we need?
1.
1 minus, and in this fraction, let's factor that.
4 and 2.
X minus 2. X plus 4.
Yep. So what's my common denominator?
X minus 2. X plus 2. X plus 4.
Yep. All of these. X plus 2, x minus 2, I already have an x minus 2 there, so I don't need to count it again. Now, if I had another one, I would count it again. So if there were 2 of these, I would have to add that in. And then an x plus 4.
Whoa.
Why wouldn't you
There
put-
are 2 of those.
Why wouldn't
No,
you-
no, 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 no.
Not on the
look.
same side.
Oh, on the
Not
same
on the-
side.
not
on
the
the
same side.
Okay.
Okay? Now, what do I need to multiply this fraction by?
X plus 4.
I'll get to your question in a moment. Minus 2. I need to watch out for that minus. What do I need to
Plus
multiply
2.
this fraction?
X plus 2.
X plus 2. I need to be careful when I distribute this negative. Yes, Emma, your question.
No. mm. You said that whichever one's greater.
Okay, I have the most of those. This one has none. Tie, just choose one, and the most of those. That's my common denominator. Don't make it unnecessarily hard. I look at this fraction, this first fraction, okay, that has to be my common denominator, right? So I copy those down, right? I look at this fraction. Do I already have an x minus 2 in my fraction? Yes. Do I have an x plus 4? No. So I add that one in. If I had an extra x minus 2, well, I've included one of them, then I would need another one because this one has 2 of them. Okay? Please, don't make it unnecessarily hard. It's just like if I had a squared plus 1 over ab. What is my common denominator?
A squared B.
A squared b. Right? I have 2 a's here. I already have counted an a, right? And a b. All right, now what do I do?
Now you just
Distribute.
distribute. So 1, or x plus 4, negative 2x minus 4.
I have a question, Mr. Ken.
Did it right.
Where'd you get that 4 from?
What for?
1 parentheses x plus 4 parentheses.
Fact.
That's
Okay.
what the other one didn't have.
Look,
Basically, one of
look,
them have
look
one.
at our common denominator. What is this fraction missing?
A 4.
The x plus 4. So I need to, it's just like if I had, okay, what is this fraction missing?
A
The 3, 1 times 3. And this fraction is missing a 2. It is the same thing.
So if you have 2 of the same on one side, you put both of them whenever you get to your second step.
I'm going to do one last example to try once again to illustrate the point. And then we might need to look at some after-school tutoring to help you out. All right, so we simplify this. What do we get?
Negative x.
And then the 4 and the minus 4. And then we have this. So is there, oh gosh,
What?
x plus 2 times x minus 2 times x plus 4. Okay? And there's nothing to factor. So
Oh,
I'm done.
wait, Kane, one more thing. What if you cancel the x plus 4 with the x plus 4? Oh, never mind, you can't. Nah,
I
never mind.
cannot cancel
I know.
through addition, subtraction,
That was
essential
simple.
skill. All right, I'm going to have one where we have already factored. I don't care what the numerator is because we aren't actually going to do it. We're just going to try to figure out what our denominator is. Okay, let's try to figure out our denominator. What is our common denominator?
X plus
1.
X plus 1. X plus 2.
squared, right? X plus 2 squared.
Okay.
Yeah.
I automatically, by default, must have all of this denominator.
Yes.
I have to, all right? Because this is part of what I'm adding. I have to have all
That
of
would be
it.
X plus 2 squared, right?
I have 2 of them, right? I have 2 of these, so I need both
But you
of
can write
them.
it squared.
And-
that was a 12, sorry.
And I have this. Now, as I look at this fraction, look, do I have one of the x plus 1s? Yes. Do I have the second one? No. So I need to add that one in. So now I have that one. I have an x plus 2 here. Do I already have one of the x plus 2s?
Yes.
Yeah.
Yes, done. All right, so now what do I need to multiply that 2 by? Well, this denominator was missing
X plus 1.
one of the x plus 1s. And this denominator was missing
One of the x plus
Plus
2.
2.
one of the x plus 2s. And then multiplies, actually we might as well just finish it. So 2x plus 2 distributed plus
Plus 10.
5x plus 10, all of that denominator, 7x plus 12, all over x plus 1 squared times x plus 2 squared.
Why
Okay?
did you choose the x plus 1 and the x plus
Say again.
Why did you choose to multiply the 2 and the 5 by the whole?
I distributed. I need
No,
to.
no, not that. I can distribute. I don't.
She's talking about why did you choose the x plus 1? Because it doesn't have it. Look at the things up there. It only has the denominator.
Like for the
It's missing
the 2 is
one of the
missing
x plus 1s.
1, and the 5 is missing an x plus 2.
The right one has that, the left one doesn't.
Yeah.
It's missing that.
See, you pretty much you want everything to have the same common denominator, so that's what you're multiplying it by. To what makes it get the same common denominator.
I have 2 of these, right? So this one wins. I need the. We're getting hung up on the same thing over and over and over again. You know how to do this, right? Right? Okay. So 2 over 2 times 5 plus 3 over 5 times 5, right? Don't get hung up over something you do know how to do. I have, what's my common denominator? I have 2 of these 5s right here, so I need both of them. Would you agree that would, if I have 2 of these 5, that includes this 5 right here?
Yes. And an extra.
And then,
So with the 3, you would write 3 parentheses x plus 2?
and then I need an I2. Now, what is this fraction missing?
The other 5.
Extra 5.
The extra 5. What is this denominator missing?
The 2. 3
The
plus
2, right?
times-
So I have 10 plus 6 all over 50.
50.
See, here's the thing. My common denominator of this is not 250. That's a common denominator, but the least common denominator is 50. Why? Because 50 is a common multiple of 50 and 10, right? Common
Hey,
multiple.
Mr. Kane, I've got an easier way to figure that out if it helps. Both of those can go into 50, so can't you multiply the 2 by 5 and the 3 by 2 and get 16
Okay,
over?
right, but what you're saying is not going to be easy to think about in this situation. So you need to, you're counting, guys, you're counting. Last time, 1 over x cubed times a plus 2 over x squared times a squared. What's our common denominator? That's all I want you to figure out. Write it down right now, what you think the common denominator should be. You should say x cubed times a squared. Okay?
Hold your power.
I have 3 x's right here, 3 of them. Would you agree that includes an x squared? Yeah, because I could rewrite x cubed as x squared times x. That includes the x squared. I have a squared. That would include the a. So what do I multiply that first numerator by?
X squared.
A,
A. Plus, what would I multiply this one by?
x.
An x. Done. That would be the answer to that question. Okay, take out your books